Welcome. In this series of podcasts, we're going to review medians and midsegments. So the three medians of a triangle connect to form the centroid. Right? So the centroid is where the three medians intersect. Right? So if you were to find all three medians, how do you find the median? Right, you find the midpoint, and you connect midpoint to opposite vertex. There's a relationship between the three segments that create the two segments that create the median and then the whole median. Right? So we have a smaller part. The smaller part goes from the midpoint to centroid. So this is midpoint to centroid. And we have a larger part that goes from the vertex to centroid. Add those both up and you have the entire median. All right, so the length of each piece is split into three pieces at the centroid. From the vertex to the centroid is 2/3 the entire median. From the centroid to the midpoint is 1/3 the entire median. Right, so now, if the entire median is 9, right, then the thicker piece, that's the one that's, this is vertex to centroid. Right. That piece would be 6. Well, how did they get 6? You just take 2/3 multiplied by 9. Right? And you could reduce that, right? So let's say if you didn't reduce, right, that would be 18/3, which is 6. If you did reduce, you could use a different color pen. You could divide 3 and 9 by 3, and you'd still get 6. Right? So that length there is 6. From the thinner piece is the midpoint to the centroid. Right? And if you take 1/3 times 9, that's the same as dividing 9 by 3, and that's going to be 3. And if you add them up, 6 plus 3 equals 9. Notice that 2 times 3 equals 6. So if I were to double the distance from the midpoint to the centroid, I'd have the same length as the vertex to the centroid. And that's because, this is it in. All right, so this is in your notes. So I'm going to move this out of the way a little bit. And so 2 times 3 equals 6, and that's because the midpoint to the centroid is half the length of the vertex to the centroid. Or you could think of it the other way, and that is if you took 2 midpoints to centroid, two of the smaller pieces, they would equal one of the larger pieces, vertex to centroid. Right? And if you think about it logically as you're solving these problems, right, the relationship, it's not random. It's a very clear relationship, right? If I divide something into 3 pieces, and this one counts for 1 piece, and this one counts for 2 pieces, right? This one's going to be twice as big, and that's because this one is 1/3 and this one is 2/3 the whole length. And if you multiply 1/3 times 2, you get 2/3. All right? So just kind of think of it that way. All right? So there's all the relationships that you get out of the median. Now the median is actually a really important point, and it's important for a lot of things. So I'm going to digress just for a second from solving medians and just show you why the median's a really important point, and then I'm going to show you how you could actually find the median if you had, say, some triangle. Right, so a triangular model of uniform thickness and density, right, so in other words, it's the same thickness all the way through, will balance at the centroid of the triangle. For instance, in the diagram shown at the right, the triangular model will balance if the tip of the pencil is placed at the centroid. And you can try that out yourself. Right? If you find the centroid, and you can't just do this with like a paper triangle, right? That's too flimsy. But like say you had a cardboard triangle or something else that's as thick as that. Right? So if you had a cardboard triangle, or any triangle as or more thick than that, you can balance it on the tip of a pencil at the centroid. I can only write faster. You can balance it on, not at, on the tip of the pencil. My brain's thinking faster than my hand can write. On the tip of the pencil at the centroid. What happened to our end there? You don't have to write this down. This is just information. It's also known as, the centroid is also known as the center of gravity. So not just triangles have centroids, although it's a little clearer how to find them. Everything has a center of gravity. Everything technically has a centroid, even you. Right? They have to know where the average person's center of gravity is when they, for instance, design railings. They have to make sure those railings are taller than the average person's center of gravity. Right? So everything has a center of gravity, even you. Right? So here's how you would find it, how you would find the centroid if you have a triangle that is cut out of cardboard, for instance. And all you need is a compass, a ruler, and a pencil. That's it. And I already have the steps up here, so you're just going to kind of watch it go. All right? And I'll explain the steps as I go. All right, so to find the center of the triangle, what you're going to do is you're going to, so now you have to find the midpoint, right? Well, how can you find a midpoint? You're going to construct a perpendicular bisector. That'll give you a midpoint. As a matter of fact, you're going to construct 3 perpendicular bisectors. 1 for each side. Right? Those perpendicular bisectors will intersect the side of the triangle. I'll put sides because we're doing more than one. Sides of the triangle at the midpoint. And actually this wouldn't be too difficult for you to do. I did it color-coded, makes it a little prettier, but you can do it with anything, especially, and the bigger your triangle is, the easier this is actually. All right, so here's my first midpoint. All right, so all you do is you take the compass, so you can watch the compass move. But I felt we've done enough perpendicular bisectors that I was fine just having it up here. I'll try to open it the same length I did before, or close to it. I mean, I had this open really wide. All right, so it's got to be, I ought to have it open pretty wide, right? It's got to be more than halfway. I don't have to know where the midpoint is to do that, but I have to have it open more than halfway. All right, so then you would just do the arc on one side and the other side, and then you just flip it around, right, and do the same thing on the other end point. Right? That's all you have to do for a perpendicular bisector. Right? For a segment, you just put the compass at the end point there, and the same arc above and below. I don't have the exact same arc as I had before, but it just kind of gives you the idea. All right? And so where those two arcs intersect, that's your perpendicular bisector. Okay? So that particular segment is perpendicular to our side, which our median's not going to be, but that's just, in general, it's not going to be, but that's just going to give us where the midpoint is, right? So the only thing we're using the perpendicular bisector for is to find the midpoint. That's it, right? After that, I don't need it. All right, so let's just do that 2 more times. All right, so there I created the perpendicular bisector for that large side up top. And again, we would have put the compass here and here, right, opened it more than halfway, drawn the arc above and below, and then connected. This one was in pink. And by the way, those perpendicular bisectors have no other purpose in this particular problem except to find the midpoints. We can get rid of them after it. And we do it one more time. Here's on the short side here. And again, you put the compass here, draw the arc above and below, make sure you open it more than halfway, keep the compass exactly the same, move it over here and above and below. And the reason, of course, that we've got this particular technique finds our midpoint is we have a bunch of radii of congruent circles. Actually, we have 4 different circles here, and we have, excuse me, 2 different circles here, and so they're all radii on those 2 different circles. Right? So you can just see that if I were to connect that to here, right, that would be a radius because I'm going from center to edge. That's why that particular construction works. And so when you're all done, you found all 3 of the midpoints. Right? Now all you have to do in our last step is to take those midpoints and go from midpoint to vertex. Right? So here, after we found the 3 midpoints, after you find the 3 midpoints by constructing 3 perpendicular bisectors, use a straight edge and connect each midpoint to the opposite vertex. Right? And where those 3 midpoints intersect, where those 3 medians intersect, right, is the centroid. So this connecting the midpoint to the opposite vertex, that's the centroid. Hope I'm not too low here on the screen, and you can still see it. Sometimes it's hard to see when you're watching this and it's at the bottom of the screen there. Right? And excuse me, I meant to write median. That was my next thought. All right, so the segment that connects midpoint to opposite vertex, that's a median. And my next thought was, which was what was in my head, the medians, and there's 3 of them, intersect at the centroid. Right? So wherever the 3 medians intersect, that's the centroid. So right there's the centroid. And all I did was use a line tool, and connect from midpoint to vertex, midpoint to vertex, midpoint to vertex. And where those 3 medians intersected, that's the centroid. You actually use the same construction to find the mid-segment triangle, the mid-segments. All you have to do is just connect the midpoints a different way. So I'll show you that. It's already constructed I'm just going to show you how to connect in a different way. So this is to construct the medians and find the centroid. Same steps except for the very last one. This is to connect and find the mid-segments of the triangle. You still do those same 3 perpendicular bisectors, but instead of connecting midpoint to vertex, if you connect midpoint to midpoint, you'll construct, oops, we lost an S there. You'll construct the mid-segments of the triangle instead. So it's exact same construction, just connecting it differently. Of the triangle, there we go. All right, so that's how you construct the median and the mid-segments. So I hope you enjoyed that. If you'd like me to do that in class with a triangle, see if I can find the centroid of the triangle, and if I can balance it on a pencil point, let me know, and I'll do that in class. All right? I believe that, yep, that's the end of my podcast, because the rest of this is on the next podcast. So in the next podcast, you can watch me solve some problems. This was just a little introduction and a little fun look at medians and mid-segments. Thanks for watching.